So good morning students, we are here with another topic of partial differential equation and that too comes in the paper 2, okay. So good morning students, we are here with another topic of partial differential equation and that too comes in the paper 2, okay. So this is a very important topic, a easier topic. People leave it and every year a 20 marker comes from this topic. A bit long question, but once you are able to understand the concept, it is very easy to do. Now the topic is the reduction of any equation to normal form, okay. Reduction of partial differential equation into normal form. So we will try to understand how to convert the equation into normal forms, okay. So there are basically three cases, okay. A equation could be parabolic in nature, hyperbolic in nature or elliptic in nature, and according to that slight variations are there in the working procedure, working algorithm, but overall the concept and the mathematics is the same. You will need some amount of knowledge of partial differential equation and some knowledge of partial differentiation, that is from the calculus portion, okay. So moving ahead, we have classification of partial differential equation of second order, okay. So suppose this any equation of second order will be of the form R S S T T. Now this R S T is, you know that R is delta square Z upon delta X square, S is small s, that is small s is delta square Z delta X delta Y, and T is delta square Z upon delta Y square, okay. So any second order differential equation will be of the form this plus f of x y z p q, okay. It will be of the form this only, second order, and this R, S and T, which are the coefficient of the second order differential of Z, okay, these are the coefficient we are interested in this form, in this question, okay. So how we parabolic, by how do we say it is a parabolic? If we form an equation, leave the equation, we form that s square minus 4rt, if it is greater than 0 then it is hyperbolic in nature, if it is equal to 0 then it is parabolic in nature, and if it is less than 0 then it is elliptic in nature, okay. We don't do anything, we just form an equation r lambda square s lambda plus t equal to 0, okay, and we find the discriminant of this. What would be discriminant of this? D, which we have read in class 10th also. Discriminant will be s square minus 4rt, and if this is greater than 0 then it is a hyperbolic, and if it is less than 0 then it is elliptic, and if it is equal to 0 then it is parabolic, okay. So the discriminant of the equation r lambda square plus s lambda plus t is equal to 0. If its discriminant is greater than 0 then it is hyperbolic in nature, and if it is less than 0 it is elliptic in nature, and if it is equal to 0 it is parabolic in nature, okay. So you only need to know this much for now, okay. Sometimes in previous, I think in the year I think 2020, there was a 10 marker question in which you have to only tell about what is this, it is differential or this is which form, that is this is hyperbolic, parabolic or elliptic in nature, the given equation, okay. It can come in your 10 marker, but the main thing is, okay. So classify the partial differential equation, okay. Clearly here in the first case we have s square minus 4rt is equal to, what will be the s? This is 4, that is 4 square minus 4rt, 4 into 3 into 2, which will be 16 minus 24, that is, sorry, this is 16 minus 4 to the 16, 16 minus 3 to the 6 for 24, that is minus 8, which is less than 0. So this is elliptic in nature. Okay, again we are taking this case. Okay, we have s square minus 4rt as s is, see, s is this 4 coefficient, that would be 4 square minus 4, r would be 4 and t would be, r is 1 and t is 4, so we get 0. So this is parabolic in nature. Okay, and again moving ahead, see, we don't have to take this first order part. See, I told you earlier also, any equation of second order differential equation, we are considered with this part only for this topic, reduction to normal form. This function we are not interested in. Okay, we are not interested in this function, we are only interested in this. We are only interested in the derivatives or the differential coefficients which are of order more than 1, that is 2. Okay, so moving ahead, so in this case we are not interested with this portion, we are interested in this portion. In this case, what is s? S is x square minus y square, so it will be x square minus y square whole square. It is minus, but minus doesn't matter. Okay, and minus 4 times rt, that is x square y square. This would be equal to x square plus y square minus 2x square y square minus 4x square y square. Okay, no, sorry, it will be minus here, so this would be plus. Okay, so this would be x square plus y square, this is plus, sorry, this is will be minus only. Okay, this will be minus 2xy square and this will be plus, so it will be x square plus y square plus 2xy x square y square. See, I think this was confusion here. Again we'll do it. Here s is minus of x square minus y square, r is xy and t is xy and t is minus xy. Okay, t is minus xy, so s square minus 4rt would be x square minus y square to the power raised whole square minus 4 times xy into minus xy. This would be x to the power 4 plus y to the power 4 minus 2x square y square. This minus minus plus, this would be x to the power 4 plus y to the power 4 plus 2x square y square. This will be x square plus y square ka whole square, which is always greater than 0. So it is again hyperbolic in nature. So I think you got the concept here. So all we have to do is that s square minus 4rt, and we have to see the relation. This is possibly this won't come in your examination. It hasn't come in your examination, but you must know it. That to know, it may come in your 10 marker. Even it has, I think once it has come in 2020 paper. Okay, but the main thing which we'll learn moving forward is how to reduce into, okay, into canonical form or the normal form. Okay, so first thing is, first you have to check. Okay, whenever a equation is given, I told you ki most of the algorithm or the working procedure is the same, just the a change we can see, a little bit change is seen when we go from elliptic to parabolic or parabolic to hyperbolic. So in the first case we study how to solve working rule for reducing a hyperbolic equation. Okay, so hyperbolic equation. So simple thing I told you, first of all you check it whether it is in hyperbolic or anything else. Okay, and then you find this equation, lambda equation, that is r lambda square plus s lambda plus t equal to 0. Okay, in the case of hyperbola, d would be greater than 0. Okay, so you will get two values of 2 lambda which will be real in nature. Okay, we know that if the discriminant is greater than 0, then we get 2 roots which are real in roots, and if the discriminant is 0, that is in the parabolic case, then we get the two equal roots, two equal values of lambda, and in the case of ellipse we get less than 0 discriminant, so we get complex conjugates. Okay, the roots will be of the form alpha plus I beta and alpha minus I beta. Okay, so what do we do here? Then the corresponding characteristic equation. See, this is the characteristic equation, that is dy by dx plus lambda 1 equal to 0. This is the character. You don't have to learn from where this characteristic equation comes or goes. See, important thing in mathematics is you have to study only for this examination. I always tell you that scoring marks is different thing and learning is different thing. Our main aim is to score maximum marks, learn the algorithm, learn the concept, apply it, get maxima, that's it. From where this comes, it will take you a whole MSc degree to understand this concept. From there this characteristics comes, or what are the existence, or what are the properties of the characteristic equations. So none of those things matter. For now you have to understand that dy by dx plus lambda 1 equal to 0 and dy by dx plus lambda 2 equal to 0, okay, gives you the characteristic equation. And what we do next, I'll teach you solving this. If we get two equation f1 xy and f2 xy, C2, we form u and v as f1 and f2, and then use this concept to find the values of p, q, r, s, t with respect to the new u and v. Okay, you will understand that, don't worry. Okay, I always say that understanding the working procedure is easy when you go by question by question. Okay, so I'll go question by question. Okay, so we have a question here, that is, this is I'll take a white pen. Okay, so we have minus 1 upon 1 plus y, minus okay. So comparing it, first of all we have to find what is r, what is s, what is t. Now this is let equation 1. Now comparing it with okay, so if we compare with this, so we get capital R to be, see this is the capital, this would be value would be 1, okay, and what would be the value of s? We don't have any term of s, that is would be 0, and for t we have minus 1 up. Okay, so this is how we get. First of all we check whether of which form it is, whether it is hyperbolic, parabolic or elliptic in nature. So we first calculate s square minus 4rt, which would be 0 minus 1 into minus 4 times 1 into minus of 1 plus, which would be equal to 4 times, which is greater than 0. So hence this is greater than 0, hence it is hyperbolic. Okay, so these things till now it is clear to you. Now what was the next step? Now next step was write the lambda equation. Okay, so what do? We write the lambda equation. What is our lambda equation? Our lambda equation is r lambda square plus s lambda plus t equal to 0. Okay, see this is the lambda equation, r lambda square plus s lambda plus t equal to 0, and here we have to find values of lambda. Okay, so in this case r is 1, s is 0 and t is okay. So we have r is 1, so we have lambda square minus 1 plus y whole square is equal to 0. See, this is our lambda square. Okay. Now so what would be the value of lambda? Lambda square is 1 plus y ka whole square. So lambda would be plus 1 plus y. Okay, and lambda would be lambda 1 would be this one, or I say lambda 2, the roots of the equation is minus 1 plus y. Okay, so we calculated the value of lambda with our second step, that is r lambda square plus s lambda plus t. We find the values of 2 lambda. Okay, so what is the next thing we have to do? The third is corresponding characteristic equation. Okay, dy by dx plus lambda 1 equal to 0, dy by dx plus lambda 2 equal to 0. So we calculate the corresponding equation, that is dy by dx plus lambda 1. So for plus lambda 1 we have 1 plus y is equal to 0. So we have dy upon 1 plus y is equal to minus dx. This would go this side and then dx will go that side, and integrating we have log of 1 plus y minus x plus c1. Okay, or we can write that log of 1 plus y plus x is equal to c1. And for other equation, that is for lambda 2, the characteristic equation would be, okay, so we have dy upon 1 plus y is equal to dx, है ना, and integrating we get log of 1 plus y minus x equal to c2. Okay, so this is the another equation. Okay, so we have calculated f1 x1 c1 and f2 x2 c2, which is we get f1 as log of 1 plus y plus x and f2 as log of 1 plus y minus x. Okay, so we get the two characteristic values. Okay, so now what we have to do? We have to select u and v such that u is equal to, we have to select u and v such that u is equal to f1 xy and v is equal to f2 x2. Okay, so we have this f1 x1 equal to c1 and f2 x2. We have calculated the f1 and f2. Okay, so we have to consider it as u and v. Okay, so our u is log of 1 plus y plus x1 and our v is log of 1 plus y minus x. Okay, so till now I think it is clear. What would we do? We first find the value of r, s, t, and then we find out that whether it is elliptic, parabolic or hyperbolic. Then what we do? We write the equation r lambda square plus s lambda plus t equal to 0, and we calculate the values of lambda. Using these two values of lambda, in the case of hyperbola, we find the characteristic equation, that is dy by dx plus lambda 1 equal to 0 and dy by dx plus lambda 2 is equal to 0. And then solving those differential equation, we get the values of u and v. Now, what is the other step we see? Now, the other step is that we have to find p, q, r, s, t in the terms of u and v. Okay, not in the terms of. Okay, this is our last step, and now our question is done. But this is the bigger step. But now, easier concept. If you know the concept of PD, then you can easily do it. Okay, we have to calculate p, q, r, s, t in the terms of u and v. Okay, so what do we do here? We write p is equal to, what is p? P is delta z upon delta x. Okay, so we can also write this as delta z upon delta u into delta u upon delta x plus delta z upon delta v into delta v upon delta x. This is the concept from P partial differential. If you have to solve the partial differential, you can do it like this only. So we have delta z upon delta u, okay, and for u differentiating with respect to x, we have 1 plus delta z upon delta v, we have minus 1. So what is the value of P? P is delta z upon delta u minus delta z upon delta b. Okay, again in the equation we need the value of delta square z upon delta x square. See, this is the equation. So we have to change this into canonical form. So we have to find the value of this. We have to find the value. We have to find the value of this and this. Okay. So we find the value of r, that is delta square z upon delta x square. This is equal to delta upon delta x, and delta z upon delta x we have calculated as delta z upon delta u minus delta z upon delta v. Okay, again going by the same principle, this would be equal to delta upon delta u and into delta u upon delta x. Same thing. This time it was z, this time the whole function you have taken as z, and first we differentiate with respect to u and then with v, plus into delta v upon delta x. Okay, so differentiating this, we get delta square z delta u square minus delta square z delta u delta v, and u by x is 1 only, and here we have plus from here we get delta v upon delta x is minus, so we will take this minus delta square z delta u delta v, and this would be plus delta square z upon delta v square. So we have the value of r with ourselves, and that is r is delta square z upon delta x square, and we have delta square z upon delta u square minus 2 times delta square z delta u delta v plus delta square z upon delta v square. So we got the value of r. Okay, similarly we have to find the value of t, since in the equation we have r and t both. Okay, so we have found the value of this, and we found the value of this similarly, and then we put in these value in the equation, we get the equation in the canonical form. That's it done, and you have the 20 marks with you. And the thing is, every year a question comes from this topic for 20 marker in UPSC Civil Service examination. So solving these 3 type of question, that is the canonical form, or the parabolic form, or elliptic form, hyperbolic form, this 3 form, if you are able to learn, and the initial till this process, till this step, all the 3 questions are done in the same way, all the 3 type of question. After that we have slight changes, and the use of differential equation, in fact the whole process is same, just how to choose the characteristic, that is the u and v difference in different questions. Okay, so we now calculate the value of v. Okay, so what do we first of all find? We find the value of delta z upon delta y. Similarly, this would be equal to delta z upon delta u into delta u upon delta y. See how this breaks, I have taught you in the topic partial differential. Okay, partial derivatives. Properties of partial derivatives, delta z upon delta v into delta v upon delta y. Okay, so for in both the cases, delta u upon delta y is 1 upon 1 plus y, and delta v upon delta y is 1 upon 1 plus y. Okay, so we take 1 upon 1 plus y. This value is 1 upon 1 plus 5, and this is also 1 upon 1 plus y, and we have delta z upon delta u plus delta z upon delta v. Okay, till now the things are easy. Okay, now the calculation part gets bit more, I think, fuzzy, but it is easy to do. A bit complex, but easy to do. See, we have to now calculate delta square z upon delta y square. This is equal to delta upon delta y into delta z upon delta y. This is delta upon delta y 1 plus y and this would be delta z upon delta u plus delta z upon delta v. Okay, so using the formula u and v, this is a function of y only, so first we differentiate this. Okay, so this would be minus 1 upon y whole square into delta z delta u plus delta z upon delta v. Okay, and plus 1 plus y, and we differentiate with respect to y. Okay, so we don't have to do anything for this case. This is maximally simplified. Now I'll calculate this thing, that is going by the previous process. What do? We first differentiate. Since see what happens is this we have to change this function into delta z by y in with respect to u or v. So we eliminate this u and v. How do we do this? We don't know the value of delta z upon delta y, but we know the value of delta u upon delta y. Okay, so this will go with the same case. This would be with respect to u. Okay, and this would be equal to delta u upon delta y plus delta upon delta v delta z upon delta u plus delta z upon delta v into delta v upon delta y. Okay, so this would be equal to I'll write this here only, minus 1 plus y whole square, and this is okay. For now this case, okay, I write the same thing. Okay, for this case it is easy to differentiate, and we got the const delta u upon delta y again 1 plus y 1 upon y, delta v upon delta y is again 1 upon 1 plus y, since we have u as log of 1 plus y and v as log of. So what can we do? We can take that common, and this would be again square. Okay, and again doing this the same process, delta square z delta square z delta u square delta square z delta v square, and 2 times this portion. Okay, so this would be plus 2 times delta square z delta u delta v. Okay, so this how we get the value of delta square z or delta y square. This is equal to q. Now the original equation in the original equation we put these values. Okay, so we put this value, we have delta square z upon delta x square, and for delta square z we have this value. So we have okay, and this is equal to 1 plus y square, 1 plus y whole square into this term, this whole term. So automatically this cancels, okay, and what we are left with is minus of delta z delta u plus delta z delta v plus delta square z delta x square plus delta square z delta v square plus 2 times. Okay, so these two cancels out, and this, if I take this to that side and this one as this side, so we get delta z upon delta u plus delta z upon delta v, and this is equal to this goes here, this is equal to 4 times delta square z delta u delta v. This is the canonical form, and your question is done. You got the 20 marks right if you do this rightly. Okay, so what we did is, initial equation was we change u in we write another function u and v with respect to x, and we form the partial differential equation, which is simpler to solve. Now this is very simple to solve. This is a simple differential equation which could be solved easily. Okay, you can solve, since the coefficient here are constant. Okay, so you can easily solve it, but this one is difficult. As a mathematician, our aim is to solve the equations, and from this method we can solve the equations of second order of partial differential equation with constant coefficient. We can solve the constant coefficient by changing that into a equation which has constant coefficient. We have variable coefficient for this original equation, and we have changed this into constant coefficient, and by this thing we are able to solve this differential equation. Okay, so there are two other cases, that are the elliptic case and the parabolic case. Okay, which I'll teach you, and this is a very simple thing, and you can do it with and easily score 20 marks in your examination by solving this one question. Thank you.